Good morning and afternoon. Thank you for joining our live webinar on the proven strategies for Windows on AWS. Today we're going to talk about the questions surrounding Windows on AWS and outline the benefits the cloud provides along with the solutions available on AWS Windows workloads using our case study on Covanta Energy as a reference.
Hi, everyone.
Our presenters today include Karish Shardi, Cloud Architect from Covanta, and Sabine Blair, Cloud Architect from Second Watch. Before we get started, we'll take care of a few housekeeping items. We will have a Q&A session at the end of the webinar, but feel free to ask any questions at any time via the Questions tab. Our post-webinar communications will include a link to download the PDF of the presentation, and after the webinar, there is a feedback tab if you'd like to rate the webinar or provide any feedback that we can take into consideration for future webinars. And with that, I will hand it over to Karish.
Thank you so much, and good afternoon, everyone. My name is Karish Chaudhary. I'm the manager for Cloud Architecture team here in Covanta. So just to give a brief background of who Covanta is, Covanta is a waste management and renewable energy industry. Covanta is a global provider for sustainable waste and energy solutions with 44 facilities worldwide. Covanta's energy from waste facilities safely cover 20 million tons of waste into clean, renewable electricity to power over a million homes and recycle approximately 600,000 tons of metal. To the business challenge, Covanta has grown aggressively through acquisitions since 2010, resulting in strains on its IT department and hampering the organization's ability to quickly integrate employees from acquired companies. Procuring, configuring, and deploying new applications took weeks or even months. In 2015, Covanta chose to work with AWS in order to reduce its overhead and selected Second Watch to lead the AWS migration. The benefits and outcome. Covanta is delivering services to users 90% faster and expects to save more than 60% in IT infrastructure costs once fully deployed on AWS. The realized outcomes, we have $1 million savings over 3 years, improved staff utilization, faster, more consistent deployments, and the most importantly, scalability. In conclusion, and I'm quoting my manager, Odalis Tejada, we are now much more efficient, and the time that we used to spend managing the internal data center is now being spent supporting our business mission of sustainability. Second Watch has been a wonderful partner in helping us plan appropriately for the migration and maintain productivity while on our journey to the cloud. And just to briefly say, Covanta selected AWS for depth and maturity. AWS allowed us to cut the amount of time to perform deployments from weeks to hours while realizing considerable cost savings. With that, I will hand this over to Sabine Blair from Second Watch.
Hello, good afternoon, everyone. Thank you so much for joining. As you can see from the title slide, this webinar is titled Proven Strategies for Windows AWS, where we will be focusing on data center migrations to the Amazon Web Services Cloud. We opened this webinar to a multitude of audiences, and this will be a very high-level discussion about how we went about the planning, discovery, and architecting of these workloads using Covanta as our case study. We will have time at the end for any questions where we can expound on some more of the technical details for those who are interested. So a little bit about myself. My name is Sabine Blair. I am a cloud consultant for Second Watch. For this webinar, as we said, we're just going to talk through Covanta, their challenges, their business goals, and the outcome of the migration. Just a little bit about myself. I am a cloud consultant with Second Watch now for roughly 3 years, and I'm a systems engineer and architect for the last decade. My focus has always been on site reliability, infrastructure as code, performance tuning, and optimization of Linux and Windows servers. And at Second Watch, I've been focused on Microsoft Windows workloads and other Microsoft data center technologies, helping spearhead migrations that we've had for several enterprise companies. And as you could see from my certifications, I have all the associate tier AWS certification, solutions architect, SysOps administrator, and developer, and I'm going for my professional cert by the end of this year. So that's just a little bit about who I am. So at Second Watch, we are the original consulting partner since 2010, which means we've been working with AWS since they've only had about a handful of services, being SQS, that's their simple queue service, S3, their simple storage service, and EC2. You can see here on this slide that we also have Microsoft Workload Competency Holder. So Amazon Web Services helps you build, deploy, scale, and manage Microsoft applications quickly, easily, more securely, and in a cost-effective manner. You can just see some other competencies that we have on the right-hand side. We also help with DevOps, and we work with a plethora of different industries, from finance to life sciences to publications, and 100% certified of our engineers are certified, and our architects, and this is very important to us because we really want to make sure that we have that level of competency and that our clients are very comfortable with working with us. Just a little bit more about some of the services that we provide. Assessments in cloud readiness, manage cloud provider, do cost analysis, security hardening, operations, and just focusing on this last bullet point, as far as operations go, we provide companies with operational readiness. That's not to be confused with the first bullet point, which is cloud readiness seen above. Cloud readiness determines whether or not your application is a good fit for the cloud and if there are any adjustments that need to be made to get that application into the cloud. For example, having an operating system that might not be supported or is legacy and then having to re-platform it into a newer operating system. Whereas operational readiness focuses on whether or not the application and the underlying infrastructure are following best practices. For example, being in a VPC, having proper logging and monitoring, IAM roles, using least permission or are your permissions too broad. So we really focus on that operational readiness aspect as well, mainly through our managed cloud as well, where we have we do monitoring, we do logging, we do basically the 24/7 NOC operations separately from our professional services division. So that's just a handful of some of the services that we provide to our customers. Trusted by leading global enterprises. So we are an enterprise workload management provider, and that helps companies accelerate data center capacity growth through the adoption of the Amazon Web Services Cloud. Enterprises have larger workloads, and therefore they have the most overhead and complexity when performing migration. So we really focus on providing enterprise customers with solutions that are highly flexible, scalable, and readily available. Those are just some to name a few. So assessment, this is just a brief overview of what we did at Covanta. We provided cloud readiness, which we brought up before, cloud readiness assessment to understand the overall application and data center footprint. We conducted several interviews with technology services and application and business owners. And we created migration plans in order to migrate apps in order of sensitivity and criticality. And just before we go forward, I cannot stress enough how important it is to conduct these interviews before you start any migration and really put the proper amount of time into it. Before starting any migration, you have to understand the criticality of the applications you're deploying. How much do they impact the day-to-day operations, revenue, interdependencies with other apps? Because if your applications have to communicate with foundational services, say Active Directory, LDAP, monitoring, those services usually have to migrate first. So identifying the personnel that supports the apps is very important, as And just equally as important as understanding who's going to be using those applications. For example, we had to train people how to set up SSH tunnels over Bastion hosts. For those just filling in, if you may be used to just RDPing into a Windows server directly, whereas you may want a company who wants to now have an extra layer of protection. They want to only go through a Bastion host and not hit a server directly. So we had to train them on how to use terminals and open Linux and open up SSH tunnels. That's just one example. Sometimes it's just literally teaching them how to access those machines. So you just really have to know the level of technical knowledge that people that are using these machines have. You may discover environments that are flat and they're not tiered. They may not have separate DMZs for their web apps. They may not have a dev, QA, and stage. They may do everything on one tier. So really identifying whether or not the customer is, using Blue Green deployments, things of that nature. Even if you're trying to mirror one-for-one with your existing data center, you always want to look for areas of improvement. If not in the current iteration, keep it in the backlog for the next iteration. So that's just some things that we did when we focused on when doing those application interviews. And this is just a migration snapshot. So the end goal was to get out of the data center. They realized that the data center was very, very costly for them, and they really wanted to expand their footprint, and they wanted to do so in the cloud. So we were given roughly a 6-month timeline. There were 200 individual hosts. 80% of those workloads were Windows-based workloads. 85% were virtualized on VMware, so that was something that was really important to take note of, that we weren't just going to be migrating VMs, but that 15% of the infrastructure was bare metal as well. So that kind of dictates the migration strategy that you choose. You're not going to be able to do a VM import on a bare metal server, so we had to be aware of the technologies that we're going to use up front and take that into consideration. So these are just some definitions that we're going to cover just before we go into some of the network diagrams to be familiar with. A DMZ is a more open portion of your infrastructure. So that would be your servers that live in the public subnet, and they're able to access the subnet, access the internet through an internet gateway. This is separate from servers that live in a private subnet that have to be accessed via a virtual private tunnel. So the VPC, that's just a virtual network topology that closely resembles a traditional network that you would operate in your data center, and it allows for the allocation of private IPs, and you define those private subnets, those IP CIDR blocks. A security group is just a firewall rule, but it's applied at the instance level. It's not applied at the NACLs or the firewall. It's applied directly on the instance. And just bear with me because my screensaver popped up. I apologize. Sorry for the silence. I'm not great at making jokes. I could have made that silence a little bit better. The region is just a geographic area containing multiple isolated locations known as availability zones. And an availability zone is basically a counterpart to a physical data center. So each AWS region is comprised of multiple AZs to provide high availability of the services that AWS provides. And a direct connect is just a service that provides an alternative to using the internet to connect to the customer's on-premise site. So if you're doing a migration and you have, these heavy workloads and you have terabytes of data, you definitely don't want that to go over the internet. That's going to be slower. You really want to have a way that from your MPLS that you could directly access AWS. So that's what that direct connect service provides. And that's something you really have to get ahead of because you're going to coordinate that with your MPLS. And that can take some time. So really want to be familiar with your needs how much data you're looking to migrate. So this is the architecture layout. I'm not sure if everyone can see this clearly. I don't know if there's a way to make this larger. But I'm just going to continue, and maybe we can make it larger at the end. So the top tier that you see are a production QA and a development DMZ. Those are the ones that were sitting in the internet gateway. As mentioned before, the internet gateway allows it for those servers to access the public internet, access the internet. If you look at that green line denotes VPC peering. So we don't want those machines, their VPC, to be paired with those that are in the internal subnet. There's nothing for them to share. However, we do have the shared services, which we talked about before when you're laying out your architecture, laying out your network diagram, laying out how it wants to look. You put those services first. So you see we have Active Directory, antivirus, the single sign-on servers, utility servers. So those have peers to the internal networks, and those have peers to the public-facing network. You also see that we have VPN connections and we have direct connects. And we're just going to go into why we have both in the next slide. So as you can see here, this is just a network layout of Covanta's infrastructure. You see that we have in those two orange clouds the AWS regions for redundancy. As you can see, we have the open internet, we have 3 separate data centers, and we have the MPLS network. And the biggest thing to take away from here is that going to that secondary DC location, you see that there's a VPN backup for the direct connect. And this is just something that we take into consideration when we're planning. You never want to be in a situation where the direct connect fails and you don't have a backup. So we created that separate VPN tunnel where migrate. We can still migrate the data and the instances over. So it's just an alternate location. Sorry. Okay, so this, as I don't know if you were able to hear that, at Covanta we had a direct connect and a direct connect to its VPC from the MPLS network, and we just used the VPN as a backup location. And just this basically says it's just a DR consideration where if the direct connect fails for any reason, you don't want that to impact your migration, and therefore you have a VPN tunnel as a backup. So just some things to consider for DR purposes and business continuity when you're doing these migrations. And these are just a list of some of the applications that were migrated. These you see are Windows Native, SCCM, Exchange 2007, 2010, Active Directory. We're able to mirror with an Active Directory connector from the on-prem to the cloud. We have Microsoft KMS, SQL Server, and the bulk of the operating systems were 2008, 2010, and we had some Windows 7 machines that were converted over to workspaces as well. And as far as the migration strategies go, for most of these applications, we were able to do a rehost. So that's basically redeploying the virtual and the physical machines as is, and we did so with Cloud Indoor. That basically allows the data to sync to the cloud while the host is online with block level replication. Whether it's physical or virtualized, cloud-based or mixed to the cloud, it does so with near zero downtime. So it takes roughly about 5 minutes to get the agent installed and up and going. And Cloud Indoor creates an exact replica of your entire workload or application in the cloud, complete with the latest storage and configuration data. So this was very, very important for the business units because they did not want to have any disruption in their day-to-day. In the end of the day, we still were doing these migrations, and we had to sync a lot of data. So, for example, say that you have a storage, a network-side storage, or you have servers that just have terabytes and terabytes of data. This allows you to non-disruptively, continuously sync that data to the cloud so that when you are ready to cut over and change your DNS and do your regression testing and user acceptance testing, that you have the latest data set in the cloud. You really want to keep that delta as minimal as possible. So because Cloud Endure uses true continuous data protection to move the data to the target location, there's practically no downtime during the cutover. So this was a very, very important requirement that the business had addressed. And after that, we readdressed each instance. We added them to the new domain as we created domain controllers in the cloud, as you saw from the previous diagram. And once we did the regression testing and it passed and we received this acceptance, we marked that server during the wave of the migration as good to go. And the biggest cost saving that you can find is easily just looking at your infrastructure and seeing if there's anything that's legacy that your business doesn't need anymore that can be decommed. It came out in a couple of application interviews. There were roughly 6 or 7 applications that could have been decommed, so that was instant cost savings right there. When you're doing these migrations, you really want to work hard to see if there's just anything. You don't want to move anything unnecessarily. You really want to keep costs to a minimum. You really want to be efficient. You really want to do a cleanup and an assessment of the environment. So we were able to find those 6 or 7 applications, which made a difference to the cost footprint overall. So as far as the cloud migration cost assessment, roughly 6 weeks. We spent 6 weeks assessing and analyzing on-premise computing environments, and we leveraged a handful of several different analytics tools. We were using something along the lines of risk. We were looking at network in and out. We were using Amazon TCO calculators. We were looking at instance server bandwidth and memory. We really put a lot of focus on sizing the instances appropriately. Not so much doing a one-for-one, but really looking at that CPU, really looking at the memory, really making sure that the machines weren't oversized, and if they were, what was something that was appropriate that we could reduce them to where they still had the same memory and compute for the applications to function. And once we were able to do that and really calculate the network output and see the bandwidth requirements, we were able to give a cost analysis from the technical side and really present them with a cost-effective solution across the public cloud. So just overall, in conclusion, Covanta was able to leverage AWS because it offered the widest range of services and technologies to support their platform. We had native support, AWS had native support for Microsoft, for Oracle, for Linux, .NET, SQL Server. Again, back to that number, 80% of their workloads. But there were some Ubuntu servers, there was Oracle, there were different operating systems outside of Windows, and they really wanted a solution that already had services ready to go that supported that. Rapid infrastructure deployment was a big one. Again, we really wanted the customers to focus on driving business, bringing innovation to the company, not spending weeks and months on deployment. So being able to leverage all the documentation that was already out there and all the support that was already out there for infrastructure as code, such as Terraform and CloudFormation, making infrastructure deployments repeatable and in a smaller amount of time, very, very important for the client. And again, just to support cost-effective and highly available solutions. Okay, so I don't have anything else. Hope that was informative.
Thank you, Sabine. This webinar will be on demand, and we'll open it up for questions that you might have right now. And we'll wait just a few minutes to start getting those in here. All right, so here's a question. Can Windows users use their existing Microsoft licenses on AWS?
Yes, and that's actually, I'm glad you brought that up. That's a really, really important question. because when you are spinning up a server in AWS, say that you select a Windows 2010 server, there's a couple of options outside of the version and outside of the service pack. It asks you, do you want to purchase the server with the license? And a lot of people pick that as a default, and then you just have a double cost because now you've purchased the license and you have your existing license already. So you really want to be mindful. If you have licenses and they're not close to expiring, you can bring your own license into the cloud. It's advised you do that because it's that's going to save you money in the long run, and that's something that not everyone is aware of.
Thank you, Sabine. How long does it take to migrate a Windows server to AWS?
It really depends. There isn't a finite amount of time per, like a definite number per se. It depends on several factors. It depends on the version of the Windows server that you're running. So, for example, you might be running a really legacy Windows server, let's say 2003, and maybe the driver is a little shaky. Maybe the drivers aren't one-for-one with the drivers that are in AWS for that version, so there's some discovery there. If we're just talking about a standard server that doesn't have a huge data set, let's say like maybe 100 or a couple hundred gigs, with Cloud Endure, you can actually migrate that pretty quickly. You could get a copy of that server in well under half an hour, or you could even do so well under half an hour with an AWS VM import-export. But naturally, if we're talking about terabytes of data, then that's something that you're going to really have to get ahead of more in advance. I think we had a server that we had to start data seeding at least a week in advance because we were looking at least 4 or 5 terabytes of attached storage that we had to get into the cloud. But just generally speaking, on average, it should take you 20 minutes to half an hour at most for just a standard vanilla server that doesn't have too much going on.
All right, great. Thanks, Sabine. What kind of support does AWS provide for Windows workloads?
Windows has a ton of support for Windows workloads. If we're talking about SQL Server, there's so much documentation out there. There's so much support. RDS already comes with SQL Server. They have always on. There's so much documentation on how to implement log shipping using transparent data encryption. They natively support Windows Server. One thing that I really was impressed with when we did the migration roughly 2015 into 2016 was just the support that they had for PowerShell. So there was a lot of automation that we were able to put in place to help facilitate the migration as well. They also had a lot of, they have a way for you to use PowerShell and implement perfmon counters for those who are using those for their monitoring purposes. So you're actually able to get those memory statistics using the perfmon counters. So I would say close to half of, I don't know the exact number, but roughly half of their workloads are Windows. Some of the other competitors were relatively new, so there's always been support for Microsoft workloads in AWS. And we took that into consideration when we started this migration a couple of years ago.
All right, thank you, Sabine. It looks like there's one more question here. What are the most important benefits of migrating Windows servers to AWS?
I would say that the biggest benefit is just how much support is out there, how much information you can find, because at this point it's pretty established. It's not anything new. A lot of stuff that you are doing in your data center you can do in AWS and in a more cost-effective way. It's a lot easier to scale your servers because you can spin up servers instantly. There's so many solutions out there for taking backups that you can restore instantly. If you're using SQL Server, there's support, again, for log shipping, for mirroring. A lot of things that you can architect in the data center, you can architect same way in AWS. One thing that you can also take advantage of is just AWS, what it provides in general, it's disaster recovery, it's backup solutions, being able to create a DR site in a different region, being able to add caching layers and, their native DNS, the native routing, being able to access your applications quickly and your websites quickly using their CDN solutions. There's just so many services. When, again, we started in 2010, there was 3 services, and now there's services that support everything from your networking to your DNS to your routing, high availability, and there's so much. They're so far ahead when it comes to just supporting infrastructure as code, using PowerShell, using Terraform, being able to spin up your infrastructure, make it more repeatable. So there's a lot of support out there for Microsoft workloads, and there's a lot of things that you can do in AWS that mirrors what you did in your data center, but also exponentially improves upon things that you have in your data center, like, being able to create domain controllers, being able to create Active Directory, or even just the option that you have a AD connector where you can sync your data from your on-prem in case you're not ready to make that full leap into the cloud. So many different solutions out there, so many ways to re-architect your data center.
All right, great. We'll give everyone a minute to submit any additional questions. In the meantime, this webinar will be on demand on the Second Watch Bright Talk channel. And again, I will include the link to the post-webinar email as well as a link to download the PDF of the presentation itself. I don't see any more questions coming through. So thank you, Karish and Sabine, for sharing, and thank you all for joining.
Thank you so much.
Yeah, thank you.